Hi everyone, today we are starting Unit 7. So in order to get started, you'll need to take out the CLT lesson that you did after your test last class, and we're going to do the check your understanding from that. If you've already done it, then you'll just check your answers with this video, and if you haven't done it, then we're going to pause here, give everyone a few minutes to get it done, and then unpause to go over the answers. This is just a review of sampling distributions for means that we learned in Unit 5 back in January. All right, so hopefully this was you were able to refresh your memory on how to do these sampling distribution problems. The main thing is on letter A that the problem said that it follows a right skewed distribution, but when we sampled 40 customers, then that is greater than 30 and the central limit theorem will apply. So it doesn't matter what the population distribution is if your sample is at least 30 or large enough, basically, for the sampling distribution to become approximately normal. And that's what the idea was behind the central limit theorem worksheet that you guys worked through. So I'm just going to briefly show some of that for a couple of minutes before we get into our lesson, just so you'll see the answers. So hold on 1 second, and I'll pull that over for us to look at. So the main idea with this worksheet was that even when your population distribution was not normal, like number 1 was uniform, number 2 was right skewed left, 4 had the peak in the either side and had a dip in the middle bimodal, 5 was normal already looking, and 8 was right skewed. So whenever we have non-normal distributions, if I sample large enough, then in the end it ended up looking approximately normal. And even getting to n equals 10, it started to get close to normal, not exactly there. So the larger the sample you have, the closer to the normal distribution the sampling distribution will become. And so hopefully you were able to fill in this box. If not, you can pause here to fill it in, but everything was on this right here. So you should be able to go there and get this filled in if you didn't get it filled in last night for your homework. So I'm going to stop showing that, but that was just the general idea. And we learned the central limit theorem before, but we hadn't seen it in action like in that applet. So then got a couple formulas we learned from our sampling distribution days. We should already know those. Mu of x bar equals mu, sigma of x bar equals sigma over square root n. And then that's your center and your spread, and then we have our shape from the sample size being large enough. And then here's all the statistical work. We've done this in Unit 5, so hopefully it wasn't too bad. Now, letter D is a little tricky when it says 99%. He wants to be 99% certain that he doesn't go over budget, which means only 1% of them go over. So if you want to think about it like that, that might be a little easier. That's how I knew to put 0.99 to the left underneath the curve. And then I do, well, actually my calculator doesn't work anymore. Well, let's see if it still does. Second vars, the trick is just never close it and your free trial won't end. So, sorry, let's see. If we do second vars 3 inverse norm, remember we can use inverse norm to get z-scores. So the area would be 0.99 to the left, not 0.99, oops, just 0.99. 0 and 1 for your mean and standard deviation, and then we get a z-score of 2.326. So that's where I got that from. So that's my inverse norm note right there that I'll just highlight in or box in red. Okay, so let's move on to our activity. How many states can you name? This should be the first activity after the central limit theorem lesson in your Unit 7 packet. And so you can take that out. And what we want to start with is how many states can you name in 1 minute? So we're going to use this class as a random sample of all AP Stat students to estimate a 95% confidence interval for the mean number of states an AP Stat student can name in 1 minute. So what I'm going to do is I want everyone to get out a sheet of paper or something like that. And we are going to set a little timer for 1 minute. So get ready, get it all set up, and then I'm gonna just show the timer for 1 minute, and you'll have until it's up to write down as many states as possible. And so we'll go ahead and do that. And then afterwards, you'll count them up, and we will enter the data together in a class dot plot. So, ready, set, go. Start writing down states. Use the name. Don't be using what's it called? Abbreviations. And no Googling. This is just a little class competition. I'm not sure if the sound comes through on my recording, so I'm just gonna pretend like it did there. Ding, ding, ding. Now, hopefully you have a list of states now and you can count them up. And if we are in class here, we'll just add the dot plot to, or you'll write the number down. And if you're at home, then we have a stacklet where we can put them into the group dot plot. Now, if we're just watching this because we missed class or whatever, I'm going to go ahead and just pretend like we got all this data right here, and you can copy this dot plot down. If you're in class, though, I really do want you to create your own dot plot. So pause here to copy this dot plot down and get all the pertinent information from Stapplet for the sample size, the mean, and the standard deviation. And then we'll go through numbers 1, 2 through 5 together before you move on. Okay, so for number 2, what type of data is this? Then we have categorical or quantitative. So with Unit 6, we were working with all categorical data, and now we'll be working with all quantitative data. So hopefully you got quantitative there. For number 3, our sample size, if you're using this dot plot, is 25. Our X bar was 19.76, and our S was 5.974. Forgot, so I had to look it up, sorry. Now, I just wanted to remind you that a point estimate is the estimate from your sample. And so if we're trying to estimate the true mean, then our point estimate is the sample mean. So I'm going to write X bar equals 19.76 there. And then we'll just do these 4 parts together before you move on to do 6 through, I don't remember, 9 maybe? Yeah, we'll see. So population, so sometimes, like I said, it's easier. We had 25 AP Stat students. It's easier to do the sample first. And then replace the number 25 with all, and that is our population. But also we have it right here, and AP Stat student. And so that's another way to tell your population. The parameter is what we want to estimate. We want to estimate the mean number of states. And so I'm going to write the word true, mean number of states. An AP Stat student can name in 1 minute, which makes our statistic the sample mean, which was going to be 19.76 states again. So what I want you to do here is do 6 through 10, actually, 6 through 10. Finish this page. Was this a random sample? Why is this important? We said it was, but I want you to think about that there. what conditions must be met for the standard deviation, and then all that. So go ahead and do 6 through 10, and then you can unpause the video once you finish to move on to the next part, which I want to do number 11 and 12 with you a little bit. Okay, so let's start with number 11. We'll come back to 6 through 10 when we get to the debrief. So we'll just do number 11 first. With number 11, when the sample size increases, the variability decreases. There's some information above that, but we should know that from our original learning and sampling distributions unit. So that's why there's a little note there. And then that thing at the top is just talking about a new critical value that we're going to be using. So we find the T star instead of the Z star. And so that's because we're using a mean as an estimate and the standard deviation as an estimate. In the proportions that we use, we only ever use the p hat as an estimate. We use it more than once, but we just use it that one estimate the whole time. Here we're increasing the variability of the general distribution by estimating more than one parameter with a statistic. So that changes the distribution from the normal distribution to something called the t distribution. What that means is we won't be using table A anymore. We'll be using table B. So table A is for z-scores with a normal curve. Table B is the t distribution of critical values. And so that's not a normal curve, even though it looks very similar to one. It's actually called the t distribution. So I'm just going to label that here. And so this worksheet says use table B to find the following, and they tell you that the degrees of freedom column here is equal to your sample size minus 1. So I'm going to go ahead and write that n minus 1 right there above df. So in our class, or no, I'm not doing that yet. Let's just do a couple examples. 90% confidence when n is 25. So what we're going to do is we find 24, because if n is 25, n minus 1 is 24. That's right here. And then on the bottom, we have our confidence levels. So 95% confidence. And we want to just match those up. Oops, it said 90, sorry. 90% confidence. We want to match those up, and we get 1.711 for that first example. T star equals 1.711. So you're just going to do that for each of those examples. You're just going to find the row with the degrees of freedom and the column. The bottom is the label where the confidence levels are, and match them up. And then you'll finish this whole worksheet. I think you can do that. And then 13 through 17. So pause here, finish 13 through 17. And then when you unpause, we'll debrief the whole activity and do our notes and our check your understanding. Okay, so let's debrief this whole activity. What type of data is this is the most important beginning, because last unit we did all categorical data with proportions. Proportions are categorical. You can answer the question with a yes or no. So I'm just going to remind us of that. And then quantitative is when you have a mean or an average, and then I like to just think like if there are units, it's quantitative. Number of states is the units. So with number 3, we have all that. Number 4, point estimate. Remember that the true mean is mu, so the point estimate is the statistic or the sample mean. And then hopefully, we know parameter is mu, statistic is x bar. Now, number 6, I was just being a little extra when I made this answer key. So we could use this class as a random sample. And so we can assume that you guys are random. I was just saying, basically, unless this block of students was a random sample of all AP staff students by being a cluster sample, it's not technically one, but we can pretend so that our random condition still condition number 1 is met. So what's going to be nice about this unit is that we're just applying everything we had learned in the proportions, intervals for proportions, test for proportions. We're just going to take all the stuff we learned from that and then turn it into the means. So we've learned means, we've learned intervals, we've learned tests, we basically learned it all. We're just going to be rewriting formulas and things like that. So number 7, you should already know, we have a 10% condition in order to use it, so that's going to be our second condition. My pen is a little bit delayed. There we go. And so then when we estimate with something we don't know, and that's when we call it a standard error. So it's SE or S sub X bar, and that equals your standard deviation from your sample over the square root of the sample size. And so that can be found on the formula sheet right here. So remember, standard error, we're looking at this one. Don't forget, your statistic is here, your parameter is here, there's your standard error there. Okay, and then would it be appropriate? So on this problem, I did this with a class of 25, which is less than 30. And so we don't know about the population and our sample size is less than 30, but it is pretty close like we talked about earlier today. The closer the sample size gets to 30, the more normal it becomes. And so hopefully it's close enough. But there is actually another method that we can use. So I'm going to call this the approximately normal distribution, normal condition. It's not called large counts because that's specifically for proportions. So we're just going to refer to it as the approximately normal condition. And there are 3 rules for it. 1, the population is normal, which we don't know about here. Or 2, the sample size is at least 30, so the central limit theorem applies, which is really great if that's the case. It's easy. Those first 2 are easy. We learned those in our Unit 5. Or, like this case, what we say is the sample data has no strong skew or outliers. So what we can do is look back up here at the sample data. And so I'm looking at that distribution. I don't see any strong skew and I don't see any potential outliers. It's pretty actually evenly distributed there. So I'm going to say that it is met because of this 3rd criteria right here. So that's our new normal condition. It's the 3rd one. We don't call it large counts. We're going to call it the approximately normal condition. And you have 3 kind of tiers that you want to work through. If the population is normal, you're done. If it's not normal, you can see if the sample size is at least 30. And if that's the case, then you can use the central limit theorem to check it. But if that's not the case, then you have to have the sample data to graph and then confirm that there are no strong skew or outliers to affect the results. So that is the gist of a confidence interval, the first 2 steps. Now let's do our statistical work and summary sentence. So first, a little bit of info about the t-distribution. We should know, as n increases, the variability decreases. And your sample size doesn't matter for the normal distribution, but it will matter for the t. We use table B or inverse t to find it. So with inverse t, that's going to be second vars 4. And so I'll show you that really quickly. Second vars 4. It's just like inverse norm. With the area, you put the area to the left. So if we're doing this 90% one, like we did already, we would put 0.05. Oops, don't put that slash. And then your df is your sample size minus 1. So the first question, 12a, asks for n equals 25, so we would put 24. And remember, this will always get us a negative, and we always write the positive version. So we have area is the left tail, and the DF is your sample size minus 1. And so you can use that instead of table B, but table B is also great. I showed you how to use it already, so either one works. Table B does have a little bit of a drawback in that. Notice not all DFs are there. So when the DF, like let's say I had a sample size of 35, then my DF would be 34, and 34 is not in there. And so you round down. So when your sample size is in there, you round down, you would use 30. Your calculator can get you any sample size and any DF. And so just that's probably a little bit easier, but if you like the tables, this works too. And then notice the last thing, this infinity, that's your Z stars. So I'm just gonna highlight those. These are all the Z stars. I'm actually just gonna highlight the ones that are most, like we have 1.645, 1.96, 2.576, there's those three that we use all the time, and see how they are right with 90, 95, and 99. Those are Z stars, so DF equals infinity is a Z star. And I'll write that right here. All right, so let's keep going. With number 13, we found the T star then for our sample, and we got 2.064. The margin of error, we already know, is your critical value multiplied by the standard error. And so in this case, that's going to be T star times S over square root N. It's going to be your margin of error for the means. And then the interval is your statistic plus or minus your margin of error. And so remember, point estimate and statistic are the same thing. And so we get this formula right here. Just going to box it since you should have already written it down. And if not, you can write it down. Now, number 16 you should be pretty comfortable with, but I do just want to remind you now that first we should have some units. Means have units. And then second, we want to capture the true mean now, not the true proportion. So don't get caught up in using the same language. It's the parameter, and the parameter is now a mean. So I have a lot of information in the important ideas box for you guys to copy down. So I'm going to go ahead and show that. The first part is really just some more detailed information about what the t distribution is and why we have to use it. So make sure you get that and you leave some room for it. And then the next is just kind of our past steps. Remember, we have our parameter is the true mean, whatever. We have to define that. Our procedure in this case is a one sample t interval, not z interval for mu. So that would be the P. We have our conditions, A, this critical value, and actual interval work is our statistical work. And then the last S we would still do, we are, whatever percent confident, etc. So I'll give you a second to copy all that down, and then you can try to check your understanding and unpause to see the result. Okay, so hopefully you were able to do it. It is a pass one because there's no A, B, C, or D, and it says calculate and interpret, and so that means to do the four-step process. Now, you guys have been learning a lot of different four-step processes. So in this case, it says for the mean healing rate, and that's how I know to do a T right there. And then interval, because it says interval. and then mean, mu, and it's one sample because it's only one sample. You can see it right there. So I'll just remind you of the steps. P, we have our procedure and our parameter. A, we have our assumptions. And there are three, the same three, random, 10%, approximately normal. Here we had no population data, and we had less than 30 in our sample. And so here is the sample data. And you can actually do a dot plot is okay, a box plot, a histogram, whatever's easiest for you. I use Staplet, and Staplet makes the dot plots right there. Also, you can draw dot plots without having to use any technology really easily. So whatever you want to do is fine, but one of those three needs to be drawn. And then we had no strong skew or outliers that you need to make this comment. Here's the formula, our statistical work. So we have I like to write the formula down and then fill it in. You need to write the DF because the DF affects the answers. So I'm trying to write must include. And then our last S is that summary sentence. And so don't forget to put units, and to say the word mean now instead. So hopefully you were able to follow those steps, and if not, you need to fill it in now so that you have them all for reference for the next time. And again, if you have any questions, make sure you reach out to your teacher about it, probably Mr. Crouch at this point for any tutoring, and hope you have a great day. Thank you so much. See you next time.